Bright Tuty. Every student matters.
In this exercise, the first question says, in triangle ABC, let's make this triangle here, and this is right angled at B. So let's make right angle here and name it B. AB is 24. Let's name this C, this A. AB is 24, right? BC is 7. Okay. We need to determine sin A and cos A. Okay. So I have just told you the Pythagorean triplet 7, 24, and third number will be 25. What I can leave it to you for exercise that you square these numbers and add and then take square root. You will get 25 here. Okay. So the third side is 25. Now what is sine of A? This angle is A, right? So we are talking about trigonometric ratios of this angle. Sine of A is nothing but opposite side, which is 7, by hypotenuse, which is 25. Cos of A is nothing but adjacent side, which is 24, by hypotenuse, which is 25, right? So this was part 1. Sin C and cos C. What is sin C? What is opposite of C? This side is opposite of C. So sin C will be opposite by hypotenuse, which is 24 by 25. And what will be cos C? Adjacent by hypotenuse. What is adjacent to C? This side, 7. 7 by 25. Right? Students, you should notice this pattern here. Sin A is 7 by 25 and cos C is also 7 by 25. So sine of this angle here is equal to cos of this angle, right? We will talk about this in the upcoming lectures also. Okay, so this is the right angle, right? Let's name these points as P, Q and R, right? So we are supposed to find tan P minus cot R. What will be tan P? You remember this TOA? This is opposite, this is adjacent. What is opposite side of P? Opposite to P is QR, right? Opposite by adjacent. What is adjacent side of angle P? PQ minus. What is cot? Tan is equal to opposite by adjacent, right? So what will be cot? Cot will be adjacent upon opposite, because cot is just the reciprocal of tan, right? So cot R, cot of this angle will be equal to adjacent side upon opposite side. What is adjacent side? QR. And what is opposite to R? PQ. So if you notice, these two expressions are same, these two ratios are same, hence the answer is 0. So tan of this angle is equal to cot of this angle, right? And what is the relation between these two angles? Angle P is nothing but 90 degrees minus angle R. What is the sum of all angles in a triangle? It is 180. So this is 90. So what is angle P plus angle R? It is equal to 90. Hence you can write angle P is equal to 90 minus angle R, right? So these two are complementary angles, sum of which is equal to 90 degrees, right? So you should appreciate this observation, which we will use in the next exercises also. Okay, this category of question we have already covered in examples. So let's see it once again. Sine of A is 3 by 4. Let's take this as a right angle. Sine of A is 3 by 4. Sine, cos, tan. Opposite by hypotenuse. So this is opposite of A. This is hypotenuse, This is adjacent side, right? Sine of A is given as 3 by 4. So let's take this opposite side as 3k, and this is hypotenuse. So let's take this hypotenuse as 4k, right? So what will be the adjacent side here? Let's apply Pythagoras theorem. So AB square will be equal to the hypotenuse square minus the opposite side squared, which is equal to 16k square minus 9k square, which is equal to 7k square, right? So side AB is equal to root of 7k. So this is root 7 into k. Okay. So what is cos A? Adjacent upon hypotenuse, root 7k upon 4k. So k gets cancelled, root 7 upon 4. What is tan of A? Opposite by adjacent. So 3k upon root 7k. This gets cancelled here, 3 upon root 7. So these are your answers. Okay. And don't get confused that two sides are 3 and 4, so that side should be 5. No. In this particular question, this side is given as 4, right? So this is hypotenuse, this is the largest side. Okay. And when you say that in a triangle, hypotenuse is the largest side, right? So you see that sine, cos, tan, right? Let's talk about this angle here. This is opposite of this angle, this is adjacent. So if you talk about sine of angle theta, it will be equal to opposite by hypotenuse. If you notice here, this side will always be lesser than the hypotenuse, right? Because hypotenuse is the largest side. Okay, in a right angle triangle, hypotenuse is the largest side. So this ratio is always, this ratio can never be greater than 1, right? So it will be always lesser than 1. This ratio, opposite upon hypotenuse in a right angle triangle, will be less than 1. Okay. In only one case it will be equal to 1, when sine of 90 is being calculated, right? Sine of 90 is being calculated, then opposite side will also be hypotenuse, and this will also be, the denominator will also be hypotenuse, so we will take it as 1. Similarly, we can say the cos of an angle is always less than equal 1. But if you take this as acute angle theta, then it will be strictly lesser than 1. So for acute angle theta, sine of theta is less than 1, cos of theta is less than 1, right? Tan can be anything, tan can take any value, because tan is what? TOA, opposite upon adjacent, right? So there is no hypotenuse here. These can take any values, right? Opposite can be any, of any length, and adjacent can be very small. So tan can reach up to infinite length. Okay. So tan can take any values, but sine and cos for acute angles will never achieve 1. At 90 degrees sine will achieve 1. At 0 degrees cos will achieve 1. Okay. So in this question, cot of A is equal to 8 by 15, right? So if you are not comfortable with cot, what you can do is you can convert it into tan. So tan of A is 15 by 8, right? So let's make a triangle here. Let's take this as A, B and C. What is tan? Tan we memorized by TOA. This is opposite by adjacent, right? So let's take the opposite side as equal to 15k and adjacent side equal to 8k. So what will be the third side here? We again apply the Pythagoras theorem. So by applying Pythagoras theorem, AC square will be equal to, right? So this is 225k square. This is 64k square. 225 plus 64 is how much? 289 k square, right? So what is AC? AC is equal to 17k. So this side can be taken as 17k. Okay. Now sin A, secant A. What is sin A? Sin A is opposite by hypotenuse. So 15k by 17k, which is equal to 15 by 17, right? What is secant A? If you are not comfortable with secant directly, you can write it as 1 by cos A, right? What is cos? So ka, adjacent upon hypotenuse, right? So we can write it as hypotenuse upon adjacent side. So secant of A is equal to hypotenuse, which is 17k, and adjacent side, which is equal to 8k. So it is equal to 17 upon 8. So this is your answer for this question. Again, the similar type of question. Here one ratio is given, we need to find all other trigonometric ratios. So first of all, we will make a triangle, right? What is secant? Secant is 1 upon cos. What is cos? Cos is adjacent upon hypotenuse. So 1 upon cos will be hypotenuse upon adjacent. So hypotenuse is 13, adjacent is 12. So let's take is 13k. If this angle is theta, then this will be 12k, right? This is right angle triangle here. Okay, so we just need to find the third side here, and then we can find all the other trigonometric ratios very easily. So what is the third side here? Side AC square is equal to AB square minus BC square, which is equal to 13k square minus 12k square. K square can be taken as common, right? K square can be taken as common. 13 square minus 12 square, A square minus B square can be written as 13 plus 12, 13 minus 12. This is 1, this is 25 K square, right? So AC is obviously 5k. So I can write it as 5k. Okay. So all the other trigonometric ratios. Tell me about sin theta. You just see these and tell me the ratios. What is sin theta? It is 5k upon 13k. What is cos theta? It is 12k upon 13k. Right. What is tan theta? Tan theta was 5k upon 12k. Okay. K can be cancelled. So your final answer will be 5 by 13, 12 by 13, 5 by 12. Okay. And similarly, you can say secant theta is 13 by 12, just the reciprocal of this. It was also given information. So talk about cosecant theta. It is reciprocal of this, so 13 by 5. What is cot theta? Reciprocal of this, which is equal to 12 by 5. So we have found all the other trigonometric ratios just by using one trigonometric ratio. So this is the algorithm that you need to follow in these type of questions. Okay. If angle A and angle B are acute angles such that cos of A is equal to cos of B, then show that angle A is equal to angle B. So in this type of questions we have already done an example where sine of A was equal to sine of P, right? So the same algorithm that you need to follow in this question. So I can leave this question for practice. Do it yourself. Right? What you can do here is you can take two triangles in which the ratio cos A is equal to cos B. So the ratios of adjacent by hypotenuse is equal in both, right? And by using the Pythagoras theorem, you take the ratios of third side also. So these two triangles will be similar triangle. Hence you can say if cos of A is equal to cos of B, then the angle A has to be equal to angle B, right? Otherwise you just rewind the video and go through that question where we proved sine of A equal to sine of B, then angle A was equal to angle B. Okay? Again, cot of theta is equal to 7 by 8. If cot theta is 7 by 8, what will be tan theta? It will be 8 by 7, right? So if you make this triangle here, let's take this as theta, ABC. Tan theta is opposite by adjacent. Let's take this as 8k, this as 7k, right? So what will be side AC? It will be 7k square plus 8k square square root, right? So it is 49k square. This is 64k square. How much is this? 49 plus 4 is 53 plus 60 is 113. So square root of 113k. This is the third side. Okay. Now we have to talk about this ratio here. So if you can see the numerator, it can be written as 1 minus sine square theta, and denominator can be written as 1 minus cos square theta. This is just a plus b into a minus b, which is a square minus b square. So 1 minus sine square theta. 1 minus, what is sine square theta? Opposite by hypotenuse square. What is opposite? 8k by root 113k square, right? What is 1 minus cos square theta? Adjacent side by hypotenuse squared, right? So this is the calculation that we need to do, and we will get our answer. K can be cancelled here itself. So this can be written as 1 minus 64 by 113, 1 minus 49 by 113. So this can be written as 113 minus 64 divided by 113 minus 49. Why? Because 113 will get cancelled. Okay. So we know that what is 113 minus 64? It is 49. What is 113 minus 49? It is 64. So you can write it as 49 upon 64. Okay. So this is the ratio which was required to calculate. Okay. What is cot square theta? Cot theta is already given. What is cot square theta? It is just square of this ratio, 7 by 8 whole square, which is 49 upon 64. Right? This was pretty simple question. Okay. Cot of A is given as 4 by 3, and we need to check whether this is equal to this or not. Okay. This is a similar question where we need to make this triangle here. Let's name it as ABC. Let's take this as right angle. Okay. What is tan? Tan is opposite by adjacent. So what is cot? Cot is adjacent upon opposite. Right? So this is adjacent. We are talking about this angle here. So let's take this side as 4k, and opposite 3. So let's take it as 3k. So obviously if you apply Pythagoras theorem on this triangle, you will get that AC is equal to 5k. Why? Because 3k square plus 4k square root will be 9 plus 16 25 k square root, which is equal to 5k. Okay, so now you have got all three sides here. So we can comment about this. Let's talk about this left hand side first. What is left hand side? 1 minus tan square a upon 1 plus tan square a, which is equal to 1 minus, what is tan of a? It is 3 by 4, just the reciprocal of this. So 1 plus 3 by 4 squared. So we can write this ratio as, this will be 9 by 16. So we can write it 16 minus 9 by 16 divided by 16 plus 9 by 16. So 16 gets cancelled. You just calculate this, you will get this, right? So 16 minus 9 is 7, 16 plus 9 is 25, right? So left hand side here is equal to 7 by 25. Let's see what is right hand side. Cos square a minus sin square a. What is cos? Cos is adjacent upon hypotenuse. So 4k upon 5k. Squared minus, what is sine? Sine of a is opposite upon hypotenuse. So 3k upon 5k squared again, right? So if you see, we can cancel these k's. So this is 4 square by 5 square minus 3 square by 5 square. 5 square can be taken as LCM. This is 4 square is 16 minus 9, which is 7. So right hand side is also 7 by 25. Hence we can say that this relation is valid for this particular condition. Okay. Hence left hand side is equal to right hand side. Okay. This is again a similar question. There is a right angle triangle here. It is right angled at B, so let's name it as B. Let's take it as A and this as C. Tan of A is given as 1 by root 3. What is tan? TOA, opposite. What is opposite? This one is opposite. So let's take it as K. Adjacent, let's take it as root 3K. Okay. Why I have taken it as K? I have multiplied this by K and this by K. I have taken opposite as 1k and adjacent as root 3k, and it will satisfy this given condition. Okay, so we have written it based on the given condition. So we have to find these values, sine of a into cos c plus cos of a into sin c. So we will require this third side also. So let's apply Pythagoras theorem here. AC square is equal to k square plus root 3k whole square, which will mean 3k square, right? So it will become 4k square. So AC is equal to 2k. So this side is equal to 2k. Right? Now I can write sine of a. Sine is opposite by hypotenuse. So k by 2k into cos c. This angle is c. Right? Cos is adjacent upon hypotenuse. What is adjacent to C? This one. K upon 2K. Right? Plus cos of A. What is adjacent of A? This root 3K. Upon hypotenuse, which is 2K, into sine of C. What is opposite of C? Root 3K upon hypotenuse, which is 2K. Okay. So from here we can calculate this ratio. This k will get cancelled everywhere, right? So this is 1 by 4 plus root 3 into root 3 is 3 by 4. So this will become 4 by 4, hence it is equal to 1. So this question, this expression is equal to 1, right? Okay, we need to find another one here. So we will use the already calculated information. Cos of A is root 3 by 2. Cos of C was 1 by 2. Sin of A was 1 by 2. Sin of C was root 3 by 2. Right? So we can calculate this right here. This is root 3 by 4 minus root 3 by 4 and equal to 0. So this expression is equal to 0 for this particular triangle here. Right? Okay. In triangle PQR, it is right angled at Q. Okay. PR plus QR, this PR plus QR is equal to 25 centimeters. This information is given. And PQ, this side is already given as 5 centimeters. And we need to determine some trigonometric ratios related to angle P. Okay. So for determining these ratios, we need all three sides. We have got just one side and we have got this condition. Okay. We have got side PQ, PR and QR are still unknown. So we need two equations to find PR and QR. And what I can do is I can make second equation by applying Pythagoras theorem. By Pythagoras theorem, I can say PR square is equal to PQ square plus QR square, right? PQ square we already know, 5 square is 25 plus QR square. And from here, what is PR? PR is 25 minus QR. So I can write it as 25 minus QR whole squared. Right? Okay. So this is, if I solve this one, left hand side will become 625 plus QR square minus 50 QR, and what is right hand side? It is 25 plus QR square. So this QR square gets cancelled, right? Okay. So this is 50 QR. We take it on right hand side. 50 QR will be equal to 625 minus 25, which is 600, right? So this 0 gets cancelled. 60 by 5 is 12. So QR is equal to 12, right? Now if I put QR equal to 12 here, I will get PR equal to 13, right? So now I have got all three sides here. Now I can easily say that sine of P is equal to, opposite is 12 by hypotenuse 13. What is cos of P? Cos of P is equal to adjacent, which is equal to 5 by hypotenuse, which is equal to 13, and tan of P is equal to opposite by adjacent, which is equal to 5, right? Tan of P is opposite by adjacent, 12 by 5, right? So these are the three ratios that we were supposed to calculate in this question, right? Thank you for this lecture. We will continue with the questions in the next lecture also, and we will do some of the questions from board point of view and some extra questions for little more understanding.